Okay, give me an example of a function. Give me something kind of simple but not too hard.
X squared plus subtract 5x plus.
Sure. Let's just do that even. X squared minus 5x. Okay. If that was your graph, here's what it would look like. So x squared minus 5x. Okay. What if I were to tell you that you plug some numbers in for x, you get y values back. And then I said, after you're done though, put a negative out front. So what happens is all of your positives become negative, and all your negatives become positive. So here's how that would look as the equation. You'd go negative bracket x squared minus 5x. So like it's the exact same equation, just with a negative outside of it all. How do those graphs look compared to each other? And the idea is that they're flipped from there. So the idea is you put in money, it spits back money. Now if you had a positive number, now it's negative. If you had a negative number, now it's positive. So like maybe look at the table of values. Maybe that'll help. If the first graph was supposed to be 6, now it's negative 6. If the first graph was supposed to be negative 4, now it's positive 4. See how these two columns here, they're basically flips of each other? That caused the graph to go head over heels. So that's what a negative outside the brackets does, is when you're done, what was positive is negative, what was negative is positive. Yeah. But the other way of doing it is, what if we put, oh, what was my original one? It was x squared minus 5x. What if, rather than putting the negative outside of everything, what if every single x, before you plug it into the vending machine, becomes negative? So before you start, all your x's become negative.
You just flip the other way.
It flips the other way, is what we discover. So, do you see how this one here, I'm putting the negative inside the function? So like, before you start, I make all of your numbers negative. Well, so that's where the original one was. Here's where the other one was. They flipped this way. The term we use is reflected. Does that make sense at all?
So the one where when it does like that way instead of that way,
Yeah.
what makes it do that again?
Okay, so what happens for this one here is you used to have like say positive 3, right, as the number you plugged in, right? Well, rather than having positive 3, this positive, well, let's go with this number here, this positive 5 has now become this guy's negative 5.
Okay.
This positive 4 has now become this negative 4, because before you even plugged it into the vending machine, I changed it before you're allowed to start.
Okay.
Does that make sense? So, like, this number here of negative 2, sorry, positive 2, now goes over here and becomes negative 2. Actually, this is a good talking point. I have a term here. It's called an invariant point. And do you guys know the term vary, like V-A-R-Y? Like, talked about that before? Differ, change, yeah. So if something is invariant, it means it doesn't change. What is the one coordinate that would not change? The intercept, the y-intercept at 0, right? Let's say I gave you an x value of 5, well, then you'd have to make it like, say, negative 5, right? Wherever you have intercepts, they don't change. So, okay, this one's on vertical reflections. So vertical is head over heels. Okay. If you're trying to flip something head over heels, let me just draw a quick picture here. You have something right here that flips to become something right here. The one point that doesn't change would be the 0 right there. Does that make sense? So this would be flipping something head over heels. The other possibility is horizontal reflections. That would be like if you had a graph over here and you flipped it to over here, the one point that wouldn't change
Where they cross the line.
would be the y-intercept, which is also where they cross.
Okay.
Yeah.
For vertical, it would be the x-intercept.
Yeah, so for vertical, it's the x-intercept. For horizontal, it's the y-intercept. Does that make sense? Because that's the one point that doesn't change, right? If I try to turn a +1 into a -1, it changes. But if I try to turn a 0, it just stays as 0.
For the vertical ones, can they have 2 invariant points then?
Sure, you can actually have a couple of invariant points. Yeah, it depends on the type of function. So one last note here. What happens in this one is your x value stays the same, And whatever your y value becomes, it becomes negative that. Okay, so that's flipping head over heels. Whereas horizontally, what happens is your y value stays the same, and the x value becomes negative. So let me just try some examples here. I think you guys will get it. From here to here, what happened? Okay, so I would describe this as negative f of x. Outside the brackets, it flipped head over heels. And then same thing with this one. This one also flipped head over heels, and this one also flipped head over heels. So everything on this slide is going this way, so a negative outside the brackets. So like after we're done, we make everybody negative. Whereas on this slide here, so this would be f of negative x. This means before you plug your numbers in, change all the x's to become negative. That makes sense? So this one flips this way, and this one flips this way.
So it's the same concept of like us before we add to x,
Right.
or like before you multiply to x.
Here we're just flipping all your numbers to another number, right? So like, in this example here, you plug your number to the vending, like I give you $1, the function does whatever it does, it gives you back $3. And then after that I say, no, it's negative. Right? And it flips it upside down. On this function here, you go in with $1 and I say, before you start actually, make it negative. Then plug it into the machine and it comes back out. So one is before, one is after.
It's kind of like the same concept of like instead of x minus 1, or like x in a bracket and then minus 1.
Mm-hmm. It's the same thing, it's the inside-outside concept.
Can you explain horizontal reflections are when you do it before, like when it's under the
Yeah. So what's happening here is like, say your equation was supposed to be x squared plus 3x. What I'm going to tell you is, you don't get to plug in x. You have to make whatever your x value was negative. And then again here, you were supposed to plug in a number, but before you're allowed to plug that number in, I'm telling you, make it negative. What that does is it takes all of your x's from like, say, where's a good one? This one over here, this guy used to be at 2. Well, I'm telling you now, you're not allowed to use 2, you have to make him negative 2. Which is why this point that was right here is now over here at negative 2. This point that was at 3 is now over here at negative 3. This point at 4 is now at negative 4. And everything flips that way.
Okay, I'm just trying to visualize.
Can I try some more examples? I mean, that's kind of the hope here is we'll just solidify with more examples. So before I even start, if this is f of x and this is negative f of x, first question, are we flipping, I'm going to do a lot of visuals here. Am I flipping this way, so like side to side, or flipping up and down?
Up and down.
Okay, what this means is when we get our answer, our y value, if our y value is positive, it's now negative. And if our y value is negative, it's now positive. So let me plot these points first. Negative 5, negative 2 would have been down here. Negative 1 and 3 would have been here. 3 and 2, and 6 and negative 4. So here's what this meant. I gave you negative 5. You were supposed to get negative 2. But that negative sign means actually, I don't want you to have negative 2 anymore. Let me phrase this. Old y should have been this. New y is now going to be 2. So then this guy would go up to here.
Oh, okay.
So then negative 1 was supposed to give you back 3. But after you're done, I'm going to say, no, you don't get 3, you get negative 3. So then this positive 3 would flip down here to give you negative 3. And then so on and so on. 3 was supposed to give you 2. But here's the key. After you're done, I say, no, you don't get 2, you get negative 2. So this guy goes down to here. And then 6 was supposed to give you negative 4. But after you're done, I say, you don't get negative 4, you get positive 4. And so then that guy comes up to here. That makes sense? So like a graph that would have looked like this got flipped upside down.
If you like took all the
So does everyone see how it's been flipped head over heels?
Yes. So you have the function.
Yep, so like you plug money into the vending machine, you were supposed to get back a chocolate bar, you now get a negative chocolate bar. Does that make sense? So everything that was positive is now negative in terms of its Y value. I don't know. The analogy breaks down a little bit, doesn't it?
It makes sense though.
What was that? Oh yeah, go. Can I do the opposite one of these? Maybe just watch. I'm gonna do it as though it was y equals f of negative x. Just to make sure that we got the idea here. So I'm just gonna erase the, which one was the new one? This one?
John Friedman, can you please come to the office? John, please come to the office.
So what would have happened if we did it the other way is your y values will now stay the same, but your x value, you used to be plugging in $5. Sorry, you used to be plugging in -5. Before you start, I now tell you actually plug in 5. And you used to be plugging in -$1. Before you start, now you plug in +1. You used to be plugging in 3, now it's -3. You used to be plugging in 6, now it's -6. So for this one, it's just the x values that change. So what happens is like this guy goes to here, this guy goes to there, this guy goes to here, and that guy goes to there.
You ever seen both of them?
Yep. Of course. If you can ask a question like it, it's probably possible. All right. So do you guys see how this one here, they've been flipped side by side now? Make sense?
I think so.
Okay. I just got more pictures here. Why don't we try doing this then? Why don't you guys try doing this? I'll do one, you guys do the last 3. If I give you y equals -f of x, the negative means afterwards we want to flip it head over heels. So let's see, how would I draw this? This guy would go up there, down to there, back up there. Does that make sense? Kind of how it's been flipped upside down? Where are the invariant points?
Those two spots where they cross.
Actually, there's 3. There's one where they cross right here. There's one where they cross right here, and this one also where they just barely touch each other. Those would all be considered invariant points because if you try to take a 0 and make it negative, it's still 0. So why don't you guys try the last 3? See if that makes sense. Try it before I do it. Maybe. Yeah, this one here.
So we're just talking.
That's why I'm confused where you start. What do you need to know the variable?
Which one are you doing?
I'm gonna do 2. Like 2 you move horizontal.
Okay, so I'll pick this point, move it to there.
But how do you know to move it over?
Well, it was at +1, now it's at -1.
Okay.
So like this was at -3, move this point over here to +3. Lost you. Okay, so like this guy right here, this negative x right here means whatever your x value is, make it negative. So like here's an x value right here. This x value is at 1. Well, 1, I'm now going to move this point over here to -1. Here's an x value of 2. Move it to -2. Here is a value of 3. move it over here to negative 3. Is this making sense? So 4 goes over here to negative 4, and 5 goes over to negative 5. So like I've just drawn one line. Do you see how this line that was right here, all of these positive x numbers are now negative x numbers? So eventually maybe you'll figure it out and go, okay, well hang on, all of these guys right here, if I flip them, won't it look like that? Right. And then like these guys right here, I'd say, look, this guy was at negative 1, bring him over here to positive 1. And then hopefully you can kind of fill in the gaps a little bit and say all of these points flipped to the other side, whereas these guys flipped back the other way. Right? Like everybody is basically mirroring each other. Does that make sense? So like that's what happens when x is negative inside the brackets. It basically means all of your x's that were positive are now negative. This guy right here, it's outside the brackets. So what it basically means is that all of your y's are now flipped upside down. So like if this guy right here was at 2, now he's at negative 2. If this guy right here was at 1, now he's at negative 1. If this guy right here was at 3, now he's at negative 3. In terms of y values. So like on this one, take every y value, flip it upside down, flip it upside down, flip it upside down. And on this one, it means take every x value and flip it, and flip it, and flip it. Amy. It's kind of similar to what we did last day, where you can then make a change before you put something in the vending machine or after you do something in the vending machine. So like last day, we were just adding or subtracting numbers. Today, my goal is to work on what happens if numbers become, like, say, negative. So like basically the question is, what happens if you make it a negative and then you put it in? Or the other possibility is, what if you do your function and then when you're done, then make it negative? Those are the two options. So one will take a graph and make it go upside down, and the other one will make it go this way.
I'm waiting for the negative outside and the negative inside.
Yep. And then vertical is if it's outside. Like this guy would be a vertical mirror, and this guy would be horizontal. Is that backwards from what you said? Okay, this guy would be vertical, and this guy would be horizontal. You just have the wording backwards. Okay. Let me do a couple more of these. This guy would look like this. And this guy, let's find some key points here. Would look like that.
Does the last one not have any variations then?
No, because nothing is like on the y-intercept. Does that make sense? Because the only invariant points will be when you're doing 0. Right? Because like any other number for x would actually change. The only number that wouldn't change is when x is 0.
So the only time that L will ever cross is either at x intercept or y intercept.
Pretty much. Okay. There's one more thing we can do, then we're going to take a break here. We can also reflect things around other lines. Okay. What I'd like to do here is plot those same points that we plotted before. So just give me a second to plot these points. 5, negative 2, negative 1, 3, 3, 2, and 6, negative 4. Okay, well, what I'm going to do here is I'm going to reflect around a different line. The line of y equals negative 2, where would that be? Like, what does y equals negative 2 as a line mean? Is it up and down or side to side? No, y equals negative 2 is this line right here. This is where y equals negative 2. Like, for example, let's say I give you x is 10. Nope, 2. Negative 2. Let's say x is 9. Nope, y is negative 2. Here, x is 8. Y is negative 2. Everywhere, doesn't matter what x is, y is negative 2. So there's the line. So it's almost like, I wonder if I could do this. It's almost like we don't want this axis there anymore.
Or your new axis.
It's almost like that's my new axis. So then could we flip this over? So for example, like this point right here is on the axis already. It's going to stay there. This point here is 1, 2, 3, 4, 5 units away. So then I would make it 1, 2, 3, 4, 5 units below.
This is weird.
It's a little different. This point right here is like 1, 2, 3, 4 units above. So then 1, 2, 3, 4 units below. And then this guy right here, this is kind of confusing. This one was 1, 2 units below. So now it would go 1, 2 units above. And they would cross right here on the actual line itself.
That's not
So not the intercept, but where it was negative 2 and where it was negative 2. Those will be the invalid points there.
So just when black equals a definite number.
So like if I tell you that we're reflecting around a specific line, then it's a little bit different.
That becomes your new
That becomes like your new axis.
Okay.
Right? So then what would have happened is this point at 5, negative 2 would still be at negative 5, negative 2. This point that would have been at negative 1, 3 would now be at negative 1, negative 6. This point that would have been at 3, 2 will now be at 3, negative 5. And this point here that would have been at 6, negative 4 will now be at 6, 0. Okay, long story short then. If you put a negative inside the brackets, it flips things this way. If you put a negative outside the brackets, it flips things this way. And then review from last day, if you add a number outside the brackets, it goes like up or down. And if you add a number inside the brackets, it goes side to side.
So inside, side, side, outside.
That's pretty much it, yeah. All right, go take 5. I'll finish my notes when you get back. Okay, why don't you guys grab a calculator? Before I do these next slides, let me try giving you some more examples to maybe make my point first. Do you guys remember how to do an absolute value graph on your calculator? Okay, do you guys remember what an absolute value graph looks like?
Yep. That's a V.
It's like a V. So on your calculator, if you want to get an absolute value graph, go second, catalog. It'll be ABS, absolute value, I think. And then I'm just going to throw X in there.
0.
Second sorry, yeah, it's right underneath 0. Can you guys find that? Some of your calculators, if they're like the fancy new ones, will give you like the square lines next to it.
It does.
And if yours is like the old emulator I have on my calculator now. Either way though, you should get this graph here. Whoa, okay, too fast then. Okay. Can you guys do the absolute value of X? Which yours might be like 2 lines with X between. To find absolute value, it's second, catalog, and then ABS is the first one.
Yeah, forced or forced?
Second, 0. Underneath 0, like second 0.
You can also go second.
Can you guys all get this graph here? Okay, just to reiterate my point, I want to try a couple of things here. So I'm going to do a second graph. I'm going to do a negative, then I'm going to absolute value, and then X. Before I press enter, the negative clearly beforehand should take the graph and make it go upside down. Hopefully it does.
It looks like
That looks like an X, yeah. Different question then. What if I were to take the negative and not put it on the outside, but put it on the inside?
it was still the same.
Like,
Because of absolute value, it just makes most of
So if I put the negative on the inside, why does it not look like anything's happening?
Because it's the same thing twice.
Because it's the same thing twice. It's like it's flipping it that way, which is like exactly back on itself. If that makes sense? Right? Because like this graph is nice and symmetrical, right? Here, let me try it like this. What if I make the second one? Have you guys ever done where you do like a solid line? So then try graphing. Here's the original function, and then the other one goes right over top of it. Because really, you're flipping it, but like since it's a mirror image of itself anyway, you can't even tell the difference.
But are you really flipping it because you're
You are.
valley?
You are flipping it. It's just the graph will look the same. That's all.
Well, like if it's negative on the inside and its absolute value, is it not still just x?
I guess I get what you're saying. Like the graph will look the same.
But
But like technically, in one example, you plugged in 3 and got back 3. In another example, you plugged in -3 and got back 3. Like either way, like
it's the same thing.
it's going to look the same, but I mean they are different equations. Okay, I want to do one more change here then. Let's try this. Let's do the absolute value both times, but rather than putting a negative number out front, let's put the number 2 out front. So go absolute value of x by itself, and then for the second one, go 2 absolute value x. So here's your normal graph, and here's the new graph. What happened?
Then how do you do both of them together? Because it goes like
2 absolute value of x. Look at the table of values.
just multiply it all.
What happened? Are you guys with me? Okay, so here's your graphs. Absolute value of x for one, 2 absolute value of x for the other. Look at the table of values.
It's double it every time.
Thank you, it's double it. All of your y values are twice as tall. If you were then to change this guy and make it say 4 absolute value of x,
4 times something.
then all of your y values would be 4 times bigger than each other. What it does to a graph is it's called a vertical stretch. What's going to happen is your graph is going to get pulled like upwards. And as you look at this graph no, calculator's there. As you look at the graph here, there's the graph. Here's the new graph. This point right here has now been pulled up to there. This point has been pulled up to there. This point has been pulled off my graph even. Does that make sense? What point did not move? Yeah, because if I take this 0 point right here and times it by 4, it doesn't do anything, right? But like 1 goes up to 4, 2 up to 8, 3 up to 12. Sure. So we could even combine them together and go like a negative 4 absolute value of x. That's what you're asking. And what would happen is your graph would then go upside down and be steep. That make sense?
The greater the absolute value.
Yo, Josh!
Well, the greater the number in front of your function, the steeper it is. So here's what that meant. Can you grab the door, please? It's going to get loud in a second here. What it meant was plug your number in, and when you're done, you double your money. That make sense? That's what that meant. Or quadruple your money, or whatever it happens to be. So you have start with $1, I give you back $1, then you quadruple it. That make sense? Well,
Well, but
negatives just become positive. That's what absolute value means.
Well, because he put the negative sign outside of it, so maybe whatever was on the
Oh, yeah.
positive, he just-
So, like, absolute value means it always should be positive. Then this means it always should be negative.
So like the x is positive and multiply by -4.
So, if you put a number outside the function after you're done, basically, it stretches it this way. So, leap of faith here then. What if I were to give you the graph, the absolute value of 2x? What does that mean? In terms of like your vending machine function concept, if I put a 2 in front of x, what does that mean I'm doing?
You get-
It means that before you put your money in, I double it, and then you put your money in. Does that make sense? And what it's going to do is it's going to change things this direction, the, what is that, horizontal direction. So watch what happens here. Actually, I should probably do the one to compare it to, otherwise you can't tell the difference, can you? It kind of looks like it's been vertically stretched. Here's what happens though. This point right here has come in. This point right here has come in. And this point here has come in by 2. Let me see if this makes sense. The function I tell you, before you put your money in, I'm going to double it. Okay. So let's say you want $10. How much do you actually need to bring them?
5.
Only 5 now. Does that make sense? Because I'm going to double your money before you start. You want to make $10. Normally to make 10, you'd bring 10, right? But if I put a 2 in front of it, I'm going to double your money. So do you have to bring as much anymore? Okay, which means that you don't need to bring 5. So everything gets cut in half this way when I put a 2 inside the brackets. Let me find an example here.
So if it was a negative, then it.
Well, negative would flip it.
Okay.
And the number itself is going to like accordion squish things, if that makes sense. Like you either stretch it this way or stretch it like this way is what happens.
Is there any way to get it like the first thing was just very wide and then when we doubled it, it went narrower? Or is there a way to get it?
Like both? Yeah, we can do both at the same time. Okay, let's just stick with this for now. If I give you absolute value of x, would it make sense that that's what this graph here would have looked like? So that's absolute value of x. What if I were to then say -3 on the outside it? So red here. The negative means when you're done, flip everybody negative. And the 3 means make everybody 3 times steeper. So it would look like this. It's negative and quite steep now.
Wouldn't half just widen it?
Half would actually widen it. Good. So 1/2 of x means you plug your money in the vending machine, and this one's not good. When you're done, I steal half of it. It's like taxes, I guess. Right? So you plug in a number, 1, gives you back 1, and then I say, sorry, actually I've taken half.
So you get 50 cents.
So you only get 50. So like 1 would only give you 50 cents. Let's say you plugged in an x value of 2. You'd only get back 1. 4 would give you 2. 6 would give you 3. What ends up happening is your graph would actually become like flatter almost. What's happened is you've actually, we say like it's squished almost, right? Like one graph you could pull everything out, but that 1/2 there actually squishes it down, makes it so you have less of what you wanted. So that's outside the function. Okay. Here's some more examples in picture format, but I want to move past that. Actually, let's do this slide here. Let's talk about what this means first. If I put a 4 in front of f of x, that's a good way of putting it. 4 times steeper.
4 times what?
Not 4 times wider, probably like 4 times smaller, probably would be a better way of putting it. Because what's happening is actually it's like squishing it down.
So if that's 1/4, well, how is it still 4 times something when the other one was?
Well, okay, so like this one makes it 4 times bigger,
1/4
and then like 4 times smaller. Maybe here's another way of putting it. You could say that it's 1/4 as big. Would that make sense instead? 1/4 as big means it is 4 times smaller. Well, what happens if I throw 1/2 on the other side?
Then you have to subtract it out.
Not subtract.
Divide. Oh.
Because this is like 1/2y equals f of x. So if I were to like times by 2, you put the 2 in front now. So that now meant 2 times steeper again. Make sense? That 1/2 on this side right here is the same thing as timesing it up to the top of the other side.
So then the next one,
How do you do with this guy then? If I have 5/3y equals f of x.
that's about 10.
Well, how do I get rid of the 3 on the bottom? Okay, so bring that up there. How do I get rid of this 5? is this graph going to be getting bigger or smaller? Yeah. One way of putting it is this will now be 3/5 as big as it used to be. Lost you, me. Okay, so it used to be 5 over 3y equals f of x. Does it make sense? I can bring the 3 up top, and then I can bring the 5 down to the bottom. Okay, well now the number in front is 3 over 5. That's like a smaller number than 1, right? So rather than making this bigger, you're going to be making it smaller. So basically it's 3/5 as big. Maybe here's another way of putting it. You're keeping 60%. Because 3/5 is 60%. So whatever your y value is supposed to be, you get to keep 3/5 of it.
So the graph would be wider than the original?
No, it'll be like shrunk down. So rather than becoming taller, it becomes shrunk. Sometimes it appears wider though. Like sometimes they look kind of similar.
Yeah, like this.
Instead of like really, really steep, it's way wider.
Like here's a good example here. Here's the first one right here. Okay. From this one to the dotted line one, what happened here is that this went down to here, and this went down to here. Now, like it also kind of looks wider, but really what's happening as well is everything's getting shorter. Like this is coming down, this is coming down, coming down, coming down, coming down, coming down. See how that works? This one right here is going up. This one goes up to here, goes up to here, goes up to here. But like as a side effect, it looks thinner. But what I want to describe to you is it's actually just getting taller. But like it also looks thinner at the same time.
So that first one is that like
So,
times bigger?
yeah, so this one would be like 2 f of x, where everything became 2 times taller.
No, that I won't be.
Like,
Yeah, like maybe 1/2 f of x, where everything became half as much as it was. So numbers outside affect things this way. Okay. I was getting a little ahead of myself perhaps then. Horizontal stretches are when you put a number inside and they go this way. You try to stretch things that way. Okay. But it's like the opposite. Okay. If I were to give you f of 2x,
It's 2 times.
it gets 2 times smaller. And that might seem weird because you're like, hang on, it's 2. But here's the rationale why. Before you start, I'm going to double your money, which means that you have to bring half as much when you start. So this 2 right here actually means that everything's coming in by 1/2. Does that make sense?
So 4 and 2 and 4.
Yes. So let me try some more examples here then. Take a look at this graph to this dotted graph right here. Do you guys see how like this vertex point moved from here to here? It's been moved out. Or let's see, this point right here has moved out here. So everything has been pulled out that way. It's been stretched. Here's what it means then. This is f of 1/2 x. Okay. What this function meant was that before you started, I was going to cut your money in half. So what do you have to do to compensate? Bring twice as much, which is why all of your x values are like twice as far out. Seems backwards. I'll try another one. This guy right here to the dotted one. Do you see how this guy right here came in? This guy right here came in. This guy came in. Do you see how everything's been shrunk in? So the equation for this guy would be f of 2x. Here's why. Before you start, I was going to double your money. Therefore, you need to bring half as much. Does that make sense? So it's kind of opposite. It's just like the f of x minus 3. F of x minus 3 actually moves the graph that way, 3 units. The reason being is that I was going to take $3 away from you. So what do you have to do? You have to bring $3 extra to compensate. And this one here, I'm going to double your money. So therefore, you need half as much. So all of your x values get cut in half.
But bottom line fraction bigger and number smaller.
Pretty much, yes. Yeah. Everything inside the brackets kind of feels opposite to what you'd think. So, let me try doing this one here. If I put a 2 inside the brackets, it means that before we start, I was going to double your money. So you need to bring half as much. So one way of putting this is that all of your x values are 1/2. Basically what it means is your graph was getting squished in like this. It's like a trash compactor. Does that make sense? Everything gets squished in like that. This one right here meant that before I started, I was going to cut your money in a quarter. So you better bring 4 times as much money. So it means all your x values are like 4, like times bigger. Which means that everything is going to get pulled out 4 times as far.
Is that because that number is less than 1?
Yeah, because this number is less than 1, then it's like the opposite. So like a fraction actually means further out. A whole number actually means squished in. It feels opposite. I promise. After a while of using this, though, it'll sink in. What's happening on this guy then? It's outside, Aiden pointed out. So is this going to affect our x values or our y values?
Why?
Yeah, this is going to make, I'm going to put a little arrow here. This is going to make everything 2 times taller. Does that make sense? After you're done, I'm going to double your money. So if you were supposed to get 5, now you get 10. If you're supposed to get 10, now you get 20. Okay, this one does some of both then. So this one is going to, the 1/2 right here, means that it's going to get squished in. Does that make sense? And that 3 means it's also going to get squished in as well. Basically, it's like the worst of both worlds. It gets compacted this way due to the 1/2 out front, and due to the 3 on the inside, it gets squished this way as well.
Can you show us on the graph how?
Sure,
Yeah,
I've got a
it's
couple examples coming up for that. I got some examples. Let's do one of these ones here. Okay, let's start with this first one here. This 2 inside. So it means that before you start, I'm going to double your money. So that means all of your x values need to be half as much as they were. So like here, what's my x value right here?
-2.
Okay, I'm going to pull it into -1. Because you were supposed to bring -$2, but now you only need to bring -1 because I was going to double your money anyways.
I don't get that.
Does it make sense?
Can you like show me algebraically or something like that?
Maybe I could do a point here. Okay, let's try this point right here. This point right here is 4, 0. That makes sense? So what that meant is if you started with $4, it's going to give you back, I guess, nothing. Okay. What this thing right, because apparently that's how this machine works. I don't know what the function is, but like the machine is, I give you 4, you give me 4, I give you nothing. Well, what this notation means here is before you start, I'm going to double your money.
So you're going to start with 8 and still get nothing.
So you were going to start with 8, but now that doesn't fit. So like, let's say you still want to end up with nothing. This seems weird. Do you need to actually bring $4 to end up with nothing then if I'm going to double your money? I'd say, well, no, you don't need to bring 4 anymore. Now you're bringing too much. So how much do you actually need to bring? I'd say just bring 2. Because if you bring 2, I will then double your money, and then you can use it. That's not working there. Can we talk later?
Should it solve because it's 2x? Why are we only doing it?
We're cutting it in half. This was at -2. Cutting it in half brings it to -1.
Now, do you always cut it in half?
Well, based on this being a 2, yes, cut it in half. But if it was a 3, we'd cut it in third. 4 would be cut in fourth.
Yeah, so that's just like the bottom of the fraction would be kind of thing?
Yeah, like it's the reciprocal.
Okay.
Here, let me sketch what this graph will turn into. Maybe that'll help. This point will move into here. This point will move into here. This point will go to here. And this point will go to here.
Shrinking.
This is what the graph will look like. Let me see if I can explain why. This was negative 4. Now it's negative 2, half as much. This was negative 2. Now it's negative 1, half as much. This was positive 4. Now it's back to positive 2, half as much. And this is positive 2. Now it's back to 1, half as much. What point didn't change?
0.
Because if you started with 0 and cut it in half, you'd still have 0. Let me try the one below it. This 4 right here means that everything would get times by 4. So we need a quarter as much to make things equal, right? Like if you were aiming for this, but before we start I'm going to quadruple everything, you don't actually need to bring as much. So all of your x values get cut in fourth. So like here's an x value of 4. It comes into 1. Here's an x value of 2. It would come into like a half. 0 would kind of stay the same. And let's see, 4 would come into 1. It would look like this. Everything has been squished in 4 times as much.
I like the money in that.
Why does
How that works for you.
why is that one spot staying the same in the middle?
This middle spot, because here was an x input of 0. So let's say you were bringing $0 along and I told you I was going to quadruple it. You still have 0, so like nothing actually changed. Does that make sense? Okay, let's try this guy here. This guy here is a 1/2. So like it's the opposite. If it's a 1/2 inside the brackets, we're going to double everything.
So is it almost like a reciprocal?
Yeah, I think I used that word on one of my slides here if I didn't say it. Did I use the word reciprocal? Write that down here on this slide here if you'd like. 1 over b is a reciprocal. Reciprocal. Do you guys remember what reciprocal means?
When you flip it,
Yeah, it's like 1 over top of whatever your number was. So it's like flip it upside down basically. That's the term we use for this. So where was I? If this guy is a 1/2, double everything. So pick me an x coordinate, like say here. This guy's x coordinate was -1. Now it's at -2. This guy's x coordinate was at -2. Now it's at -4. And this guy's x coordinate was -3. Now it's at -6. That's how it would have changed. So -1 goes out to -2. -2 goes out to -4. And -3 goes out to -6. See how everything's been like pulled outward? Almost like you're like trying to warp it that way? Maybe.
basically, if your number is set back of x, you need to move your little points. You can take a point,
Yep.
put it on the x value, and divide it.
Or multiply it, depending on which way you're going, yes. So like, okay, since this guy was 1/2, we're gonna multiply it by 2.
But I divided it by 2, and I got to 4 that you were talking about.
So like this point right, so like which point are you talking about? Like right here?
Would you know when you did the inside or the outside?
This guy right here, it's -2. So like -2, what did you do?
I went -2 divided by half.
Oh, okay, dividing by a half is the same thing as timesing by 2. So we're talking about the same thing now.
By 2 though.
Well, because another way of approaching this is like rather than considering it 1/2, you can consider it like 2 times bigger. Okay, hang on,
So
let's do
if it's
this.
in the bracket, I can divide it by the number.
Sure, you can do that. That'll work.
The numerator denominator.
Okay, here's 2 ways to do it. You could either times by 2 or divide by a half. Either way, you're getting the same number. So we are talking the same thing. I'm just timesing everything by 2, and you're dividing everything by a half. I think we're on the same page, kind of. Okay, let's try one last one here. I'm just gonna pick points one at a time here. So like this guy right here is at -3. So if I double it, which is like dividing by a half, it goes out here to -6. This guy right here is at 1. So when I double him, he goes out to 2. Where else is a key point? Down here, this guy was x of 2. So now he goes out to 4. And then this guy was at 3, he goes out to 6. So I don't know if this makes sense, but everything has been pulled outwards. I like to do a lot of hand actions in this unit. This way, this way, this way, this way, that way. That makes sense. That way, this way. How are you guys doing? Did this make sense?
I'm like,
It did
I'm
until
like more positive than negative, but not like all the way.
Okay.
It did
Like,
until the next
up
question.
there.
Okay, let me give you, why don't we just do one last example, then we'll call it a day here. Let's do an example of something that like would be a typical question then. We'll see if we can apply these skills.
Yeah, no.
Okay. Last one. Okay. I'm going to give you a cubic function with 3 roots. So we've been doing this all along. If I give you 3 roots, can we write something with them?
Yeah, crazy.
Write factors. So y would equal x minus 1, x plus 4, x plus 4. And I gave you the y-intercept. Well, that was in that one example when the y-intercept was 0, it was another root. But it is another point on the graph, though. If we know a point on the graph.
So 0 with E, the x is, and then 16, 5.
Okay, what does that help me find then?
A.
Okay, so 16 equals a times negative 1, 4, and 4. Ahead of me here. So here's my equation. Y equals a. No, I don't need a anymore, do I?
What is it?
Oh, quick question. How did you get?
X plus 4 cubed. I squared, I mean, not cubed.
Why are we dividing by negative 16?
Because negative 1 times 4 times 4 is negative 16.
You lost.
Where did I lose you? So like the x minus 1, x plus 4, x plus 4, does that make sense? Okay, then if I know the point 0, 16 is on the graph, I plugged in 0 for x and 16 for
Oh,
y.
and you multiply, but then why did you get y to negative 16? Not
4 times 4 is 16. But the negative 1 is, I just divided by negative 16. Because that's what all that is. Okay. Next question here. G of negative 2x.
Split negative.
Is that inside or outside?
Inside.
Okay, so inside means before we do anything, this graph would have been flipped upside down. No, would have been flipped side by side. And then the 2 on the inside is where it gets confusing. The 2 actually means make everything squished in. Does that make sense? That's what would happen to this graph. Okay. So if you guys have your graphing calculator, okay, first, can you guys plug in our first graph? So before we even do anything, let's plug in the one we just did. Yeah, like the one we just made an equation for. So negative 1 bracket x minus 1 bracket x plus 4 bracket x plus 4.
We just write x plus 4 squared.
Sure, that'll work too. Okay. And then graph it. Let's make sure we all understand how this graph works. Do you have the same thing as I did?
Yeah.
Okay. If we were then to do g of negative 2x, what should happen is it should flip side by side and get squished in. Now here's how I could test that. Take your equation and everywhere that there was an x, make it negative 2x minus 1. Make it negative 2x plus 4. And make it negative 2x plus 4. And let's check and see whether that fits. Does that make sense? So everywhere there used to be an x, it's now negative 2x. So here's my new equation. Why it's driving me crazy. Negative 1. So rather than writing x, write negative 2x. And then still subtract 1. Rather than write x, write negative 2x plus 4. Okay, so is everyone okay typing that second equation in? And I'm just going to make this bold so I can tell the difference between the two.
It's so cool.
Before I press graph, I just want to talk about what this meant again. The negative on the inside meant that it should go flip this way. And the 2 means that everything should get squished in. So let's see if this makes sense.
Oh, it did it.
Not that I didn't expect you to do it right now.
So take any given point. Like say this point right here. This point got flipped over to here and then got squished in.
We're so fly on my
I know, it's driving me crazy too. Can you guys see how that hopefully kind of comes together, the whole flip and squish concept? Okay. Basically, I need you guys to know 6 things. If we add a number inside the brackets, it goes either this way or this way. If you add a number outside the brackets, it goes up or down. Does that make sense? If you put a negative inside the brackets, it flips this way. A negative outside the brackets flips this way. If you like put a 2 outside the brackets, it stretches it this way. But if you put a 2 inside the brackets, it actually squishes it in.
The last 2 were.
So